Okay, going to be trying to crank out the solutions here for product sum formulas on, what is this, 8.3? 8.5, okay. Starting with number 13, find the exact value of cosine of 165 degrees. We'll be doing this without a calculator. So what we want to do is figure out if we can rewrite this as cosine of alpha plus beta, or cosine of alpha minus beta, where alpha and beta are two angles we know. So that looks like 165 is 180 degrees. Well, no, that's not an angle we know. I was going to say minus 45, but that wouldn't work. So let's see. How about 120 degrees plus 45 degrees, right? That would work. As long as we know where 120 is on the circle. So I do know that. This is, let's see, 45 degrees is right here. It's 45 degrees. And then 120 is right there. That's 120 degrees. So I should be able to use those two angles. So I'm going to rewrite this as cosine of 120 degrees plus 45 degrees. And according to the formula for cosine of alpha plus beta, this should be cosine 120 times cosine 45. Then minus, it's very important on the cosine, it's the opposite. So I'm not going to write the formulas up here because you have those from class. So cosine, cosine, and then minus, we're going to do sine, sine. So sine 120 and sine of 45 degrees. All right, so yeah, I guess I need that unit circle again. So at this angle, 45 degrees, we've got root 2 over 2, root 2 over 2. And then up here, we've got negative 1/2. And root 3 over 2. So now, cosine is the x-coordinate. What's the x-coordinate at 120? Negative 1/2. What's the x-coordinate at 45? It's root 2 over 2. Minus sine of 120, which is the y-coordinate right here, which is root 3 over 2, times sine of 45, which is the y-coordinate here, which is root 2 over 2. And so what we want to do is multiply those two together, and then we'll subtract. So when I multiply straight across here, I get negative root 2 over 4. And then minus, here I get root 6 over 4. And when I put those two together, I get negative root 2 minus root 6 over 4. There we go. Okay, now number 15. So for 15, we want tangent of 15 degrees. Tangent of 15 degrees. So we have a formula for tangent of the sum or difference of two angles. So can we look at that as either the sum or difference of two common angles? And I'm seeing that we can rewrite that as tangent of 45 degrees minus 30 degrees. Right, and so the formula for tangent, I don't have this one memorized, so this is going to become tangent of alpha, so tangent of 45 degrees. We're treating this like our alpha minus beta there. So tangent of alpha minus tangent of beta, so tangent of 30, and then over 1 plus tangent 45 tangent 30. All right, so all we need to do is figure out what tangent is at 45 and 30 degrees. So at 45 degrees, we have root 2 over 2, root 2 over 2. And tangent here is the y divided by the x. So tangent of 45 should be 1. So we're going to have 1 minus, we'll figure out what this is in a second, over 1 plus tangent of 45 here is 1 times tangent of 30. So we need to figure out the tangent of 30 parts. 30 degrees is here. And this is root 3 over 2, 1/2. Tangent is the y divided by x. So if I take 1/2 and divide it by root 3 over 2, and then we flip the reciprocal over, we get 1 over root 3, which most likely the book is going to rationalize. That's become root 3 over 3. So we're going to have root 3 over 3 here, and then here root 3 over 3. So our numerator is 1 minus root 3 over 3, and the denominator is 1 plus. Multiply those together, you get root 3 over 3. I doubt they're going to leave it like this. They're probably going to try and clean this up. So they realize there's a denominator of 3 here and here. So they multiply the top and bottom by 3. So let's multiply the top by 3, bottom by 3. And we will distribute the 3 through and distribute the 3 through here. So 3 times 1 gives us 3. 3 times this, the 3's will cancel, we'll get minus root 3. And on the bottom, 3 times 1 is 3, and then plus, here again, the 3's will cancel, we'll get root 3. So I would have taken this, but that's probably what the book's going to have. Okay, number 17, 5 pi over 12, sine of 5 pi over 12. I'm just going to double check that I'm recording and my microphone is on. Yeah, okay. So sine of 5 pi over 12. So now we're just dealing with radians. So since we're in radians, we did a few of these in class. I did the radian ones in class because they're a little harder to work with than the degrees. So 5 pi over 12. And the way I did that in class is I just looked at, some of the common angles. So our common angles are like pi over 6, pi over 4, pi over 3, pi over 2. And then if we get common denominators here of 12, this is going to be 2 pi over 12. This one is going to be 3 pi over 12. This one will be 4 pi over 12. And this one will be 6 pi over 12. So we're just trying to figure out how we can combine these by either adding or subtracting to get 5 pi over 12. And I notice I can put these two together. I can add those two. So this is the same as sine of 2 pi over 12 plus 3 pi over 12, which is really, going back to the common angle, pi over 6 plus pi over 4. All right, now we use the formula. So this is going to be sine of pi over 6 cosine of pi over 4 plus sine of pi over 4 times cosine of pi over 6. And now we just need to get the coordinates off the circle. Now I'm not going to draw the circle this time. Sine of pi over 6 is the y coordinate pi over 6, which is 1/2. Cosine of pi over 4 is the x coordinate at pi over 4, which is root 2 over 2. Plus, this is the y coordinate at pi over 4, which is root 2 over 2. And this is the x coordinate at pi over 6, which is root 3 over 2. And now we multiply these two and these two together. So we get root 2 over 4 plus root 6 over 4, which is root 2 plus root 6 over 4. So there's your exact answer. Sorry if I seem like I'm rushing, but I don't have a lot of time here. Okay. Number 21, sine of 17 pi over 12. So how can I get 17 pi over 12? I shouldn't have erased those. I did have a 6 pi over 12 up there. That was for pi over 2. I could do 6 and let me see. Well, let me put the other ones back up here. Hold on. Pi over 3, pi over 4, pi over 6. We're going to have to go bigger. This is 2 pi over 12. This is 3 pi over 12. 4 pi over 12. And then 6 pi over 12. So we know that we could get a 17, if we put together, let's say, how about these two together right here? What would these two together here be? That would be 5 pi over 12, right? So what if we had a 5 pi over 12 together with a 12 pi over 12? That would be 17 pi over 12. That still doesn't help. Here, let me try this a different way. This might help. Okay, when we cut our circle into pi over 6, we said like this was 1 pi over 6. Next one was 2 pi over 6, which was really pi over 3. And then 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, right? So when we're looking at 17 pi over 12, what we could do is we can imagine cutting these instead of into sixths, into twelfths. So this would be pi over 12 right there. Okay, that's pi over 12. And this would be 2 pi over 12 right there. 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, 12 pi over 12, 13 pi over 12, 14 pi over 12, 15 pi over 12, 16 pi over 12. Here we are, 17 pi over 12. That's where we are. So how can I get there, right? How can I get there? What I was saying is if you did 12 pi over 12, which would take you to here, then what you could do is just add pi over 12s, add 5 more of them, 1, 2, 3, 4, 5, and you'd be there. But that still does not, I guess, resolve like how we're going to get them from here. So why don't we do this? Let's take, we know together it's this, right? Let's do this. Let's do it this way. I'm trying not to confuse you, although I think I already have. Let's go back to this. Okay, let's go to that, all right? So if we do this, right, if we do those, then we know that this is really pi, plus this is really pi over 4, and this one is really pi over 6. So we know that this will achieve what we want. Let's just do this. Let's put these two together, just those two, with a common denominator. So I multiply the bottom by 4 and the top by 4, right? If I do that, then I'm going to get 5 pi over 4 plus pi over 6. There we go. That should work. What I've done is I've grouped these two together with a common denominator of 4 because that I can find pretty easily. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here's 5 pi over 4, and then we're going to add to it pi over 6, and that'll take us to here. So we know what the x and y coordinates are there. That's going to be negative root 2 over 2, negative root 2 over 2. That's for 5 pi over 4. And then pi over 6 lives over here. And those coordinates are root 3 over 2, 1/2. So we should be able to get it this way. We're using 5 pi over 4 plus pi over 6. We know that that's equal to this. We know that's equal to this, which is equal to that, which is equal to 17 pi over 12. So this should be sine of pi over 6. There's got to be a more efficient way of doing this. Those two together, like that. So let me just do a quick, yeah, all right. So now this becomes sine of pi over 6 cosine of 5 pi over 4 plus sine of 5 pi over 4 cosine of pi over 6 using the formula. The y coordinate at pi over 6 is 1/2. The x coordinate at 5 pi over 4 is negative root 2 over 2 plus the y coordinate at 5 pi over 4, which is negative root 2 over 2, times the x coordinate at pi over 6, which is root 3 over 2. And then put them together. We're going to get negative root 2 over 4, And then this will become minus because there's a minus here, root 6 over 4. And then just put them together over the same denominator and you're there. All right, that took a little more time than I was hoping it would. There is another way. It's kind of cheating, not really, but what you could do is you could take 17 pi over 12 and you could multiply it times 180 degrees over pi and then get rid of your pi's and figure out what this is as an angle in degrees. And then sometimes it's easier to come up with those common angles. So like if I did that on my calculator real quick and I did 17 times 180 and divide it by 12, 17 times 180 and divide that by 12, I get 255 degrees. And that I can see pretty clearly that that's 210 degrees plus 45 degrees. And 210 is a common angle and 45 is a common angle, so you could do it that way. But that's kind of cheating, not cheating, but you're avoiding dealing with radians by converting degrees, which you could argue is smart, I guess, if you don't like to work with the radians. Okay. Number 25, find the exact value. So 25 is going to actually work out really clean. It's sine of 20 degrees, cosine of 10 degrees, plus cosine of 20 degrees, and then sine of 10 degrees. So this is actually the formula for, if you notice it the way it's written, this is actually the formula for sine of 20 degrees plus 10 degrees. So if we started with this and broke it down with the formula, we would have this. And so you can see, the book does in their formula switch the order of these. Just be careful. When I write my formula down, I put the sine in front of the cosine, but they're the same thing because multiplication can flip around. So this is really just sine of 30 degrees. So this is the y coordinate at 30 degrees, and the y coordinate at 30 degrees is a half. And that's it. 27 is going to be the same thing, except you have to notice that this is a different formula. It's cosine, cosine. So when we see cosine, cosine like that, and then minus sine, sine, we should be thinking this is a sum or difference formula for cosine. And specifically, this would be cosine of 70 degrees plus 20 degrees, because this is a plus. If this is a minus, that's a plus. So this is cosine of 90 degrees, and that's the x-coordinate at 90 degrees, and that's 0. Number 31. Again, this should look familiar. We've got sine of pi over 12, cosine of 7 pi over 12, minus cosine of pi over 12, sine of 7 pi over 12. So that falls into the format of sine of pi over 12 minus 7 pi over 12, which is sine of negative 6 pi over 12, which is sine of negative pi over 2 if we reduce that. So negative pi over 2 on the unit circle is straight down like this, and we're looking at sine, so it's the y-coordinate, which is negative 1. All right, number 33, same thing. We've got cosine, cosine again, so cosine of pi over 12, cosine of 5 pi over 12, and let's see what we've got here, plus or minus now. Plus sine of 5 pi over 12, sine of pi over 12. So this looks like the formula for cosine of pi over 12 minus 5 pi over 12. So this is cosine of negative 4 pi over 12, which is cosine of negative pi over 3, And negative pi over 3 on the unit circle is, pi over 3 is right there. So we want the x coordinate there, and that should be 1/2. Okay, so that's it for 33. So that's just you recognizing the formulas for the sum and difference for sine and cosine, but backwards. All right, 33. No, 35. 35 now. So for 35, we have given information that sine of alpha is 3/5. And they tell us that alpha is between 0 and pi over 2. They also give us that cosine of beta is 2√5 over 5, and beta is between negative pi over 2 and 0. Interesting. And what we're asked to find in this problem are sine of alpha plus beta, cosine of alpha plus beta, sine of alpha minus beta, and tangent of alpha minus beta. So what I'm going to do is I'll probably do just one of these and then let you do the rest. Let's try and find sine of alpha plus beta. So this is going to be sine of alpha cosine beta plus sine of beta cosine alpha. All right, so in order to do the problem, I need to know what sine of alpha is, which I know. I need to know cosine of beta, which I know. I need to know sine of beta, which I do not know, and I need to know cosine of alpha, which I do not know. So this is where we took these, and we're going to do little reference triangles for these. All right, so I'm going to start off by thinking about where I am. Let's do the top one first. Okay, this one over here. So for this one, I'm in between 0 and pi over 2. So I'm over here. And sine, it's positive, so yeah, that makes sense. I'm over here. If I draw a little reference triangle like this, I know that sine is the opposite over the hypotenuse. And then I can solve for this side with the Pythagorean, a squared plus b squared is c squared, and I would get that this is 4. And my angle here is alpha. So you can see that sine of alpha is this over this. We needed to know what cosine of alpha was. So let me just from this picture write cosine of alpha is 4 over 5. Okay, let's do this one. I know that I'm between negative pi over 2 and 0. So negative pi over 2 is right here, 0 is right there. So I'm in between there. I'm going to draw a little triangle like this. I know that my angle beta is like that. And I know that cosine is positive, right? So I'm over here, that makes sense. And cosine of beta is adjacent over hypotenuse. So the adjacent side should be 2√5 over the hypotenuse, which is 5. And now I need to figure out what this is. Okay, so let me call that y. I know that y squared plus this side squared. Now when I square that side, I get 4. I square the 2, I get 4. I square the root, I get 5. So that's really 4 times 5 must equal this side squared, which is 25. So y squared must equal y squared plus 20 must equal 25. Subtract from both sides, y squared is 5. So y is plus or minus root 5. Now which one is it, plus or minus? Well, it's the y coordinate, and we're in the 4th quadrant, which means our y coordinate must be negative. So it's the negative answer here, negative root 5. So this is negative root 5. And now, remember, we wanted to know what sine of beta was. Sine of beta is the opposite over hypotenuse. So I can conclude here that sine of beta is negative root 5 over 5. All right, now I come back here and I'll fill everything in. This is equal to sine of alpha, which was 3/5, times cosine of beta, which was 2√5 over 5, and then plus, and then sine of beta, which was negative root 5 over 5, times cosine of alpha, which was 4/5. And let's see what we get here. We multiply here. We should get 6 root 5 over 25. Then we're going to have a minus because we only have one negative up there. So minus 4 root 5 over 25. And so these are like radicals. So 6 of these minus 4 of those, that leaves us with 2 of them. So 2 root 5 over 25. Okay, so that is the answer, sine of alpha plus beta. The next thing they want is cosine of alpha plus beta. So I'll just get us started here. Cosine of alpha plus beta is cosine alpha cosine beta minus, because that's a plus, sine alpha sine beta. And we already know what all these things are, right? Cosine of alpha is over there, 4/5. Cosine of beta was given to us, 2 root 5 over 5. Minus sine of alpha, which was given to us, 3/5. Times sine of beta, which we found was negative root 5 over 5. And so you do the same thing, you put them together. And then on part C, you do sine minus here. So that changes that to minus, that changes that to a minus, which changes that to a plus. And then tangent is the last one. You can use the formula for tangent. Just be careful that when you're doing tangent, if you come back and you do tangent of, let's say, tangent of alpha is 3/4, opposite over hypotenuse. Opposite over adjacent. And tangent of beta is opposite over adjacent. So you just have to pay attention. But we've got all the information we need to answer the questions. I hope that that's enough to get you going on that. Let's look at number 39. Number 39, same instructions. We want to find all those things. We have sine of alpha is 5/13. Sine of alpha is 5/13. And alpha is between negative 3 pi over 2 and negative pi. And then they give us that tangent of beta is negative root 3, and they tell us that beta is between pi over 2 and pi. So I'm going to go through the same thing. I need to basically come up with these triangles. Once I have the triangles, I can answer pretty much anything about this. So let me determine where we are with this alpha and beta, what quadrants we're in. We'll draw our little triangles, use some Pythagorean. So let's start out with that first one over there. We are between negative 3 pi over 2 and negative pi. So look, here's 0. Negative 3 pi over 2 is right there. Negative pi is right there. So, right, this is negative pi. This is negative 3 pi over 2. So we are in that quadrant there, second quadrant. Draw my triangle. And I know that sine is opposite, or you could say the y-coordinate divided by the radius if you like. And then I can solve for this side right here. So let's call this x. We have x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. Okay, so then x squared equals 49. Oh, 49. X is plus or minus 7. Seems right. 25. Wait a minute. Where did I get 49 from? Subtract 25. So 4 here, 4 here, 44. Yeah, so 44. I don't know where I got 49 from. Root 44 plus or minus. Right? And which one is it? Well, we're in the second quadrant, so the x has to be negative. So x is going to be negative root 44. What the hell am I doing? Man, my math is just way off today. This minus this, I forgot the 144, 144, 144. Yeah, it's definitely Monday. Negative 12. Okay. Wow, so x is negative 12. Negative 12 there. And so now, you know, this is alpha, right? So we have everything we need. We know sine of alpha is this over this. Cosine of alpha is this over this. Tangent of alpha is this over this. So we have everything we need to know to answer any of the questions. Now for beta, I'm between pi over 2 and pi, so I'm over here in the second quadrant. This, here's my beta. And all I'm given is tangent, which is the y-coordinate divided by the x-coordinate is negative root 3. So we have to be very careful here. I cannot put negative root 3 over 1 like that. That wouldn't make sense because my x-coordinate has to be negative, my y-coordinate has to be positive. So I need to make this positive and this is negative. And just double check, tangent, opposite over adjacent. That will give you negative root 3. So that works. And now we just, to solve for this side, which I'll call r, we know that negative 1 squared, that's this side squared, plus that side squared, root 3 squared must equal r squared. So this is 1 plus 3 equals r squared. So r is equal to 2. Because when you do plus or minus here, you don't have to worry about the plus or minus because the r is always positive. So this is going to be 2 here. All right. So now I know what, you know, sine of beta would be this over this. Cosine of beta would be this over this. Tangent beta would be this over this. I've got everything I need. So let me just show you. For this one, I'll do part D. I'll do what would tangent of alpha minus beta be? Well, according to the formula, it should be tangent alpha, I think it's, yeah, minus tangent beta over 1 plus tangent alpha tangent beta. So there's your formula for tangent of alpha minus beta. And so what is tangent of alpha? Well, tangent of alpha, here's alpha. Tangent is this side over this side. So 5 over negative 12 minus tangent of beta. Tangent of beta is this over this. So we already know that that was negative root 3. All over 1 plus tangent of alpha we just did was 5 over negative 12, but that times tangent of beta, which was negative root 3. So cleaning this up a little bit, we get negative 5/12 plus root 3 over 1 plus, when I multiply these together, the negative and negative become positive, and this is really like over a 1, so we just go across. So we just get 5 root 3 over 12. And then I guess the last thing you could do is you could multiply the top and the bottom by 12, but I mean, I would accept this just like this. Man, what is going on with my phone? Got all these emails within the last 5 seconds. Dum. 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 Okay, 2 o'clock, gee whiz. All right, let's look at 41. I'm not going to do any more of those. Number 41. Markers are so hard to erase. 41. All right, it says if sine of theta is 1/3, theta is in quadrant 2, find A, cosine theta, B, sine of theta plus pi over 6, C, cosine of theta minus pi over 3. And finally, tangent of theta plus pi over 4. All right, so what I'm going to do is I'm going to use the formulas for these three, like sine of a sum, cosine of a difference, tangent of a sum. So I'm going to use the formulas. I'm going to have to know information about theta, but then these are given angles, so we're in business. Let's just kind of do the same thing we did a little while ago, though. Let's figure out we're in quadrant 2, so we know we're over there. And sine is 1/3. So sine is the opposite over the hypotenuse, so that's 1/3. This is our theta. And basically at this point, we can solve for this side. So let's call this x. We know x squared plus 1 squared equals 3 squared. So x squared is 8, x is root 8. But it has to be the negative case because we're in the second quadrant. So negative root 8, that's x. So this right here is negative root 8. And now I know all the different trig functions. So what is cosine of theta? Well, it's this over this, so negative root 8 over 3. Okay, so this is sine alpha cosine pi over 6 plus sine pi over 6 cosine of theta. So I'm just using the formula for this, the sum formula. Sine of theta, I'm not going to do these, so let me just move down here. Sine of theta is this over this, so that's 1/3, times cosine of pi over 6. So this is common angle stuff. Cosine of pi over 6 is the x-coordinate at pi over 6, which is root 3 over 2. So plus sine of pi over 6, which is the y-coordinate at pi over 6, which is 1/2. And then cosine of theta is, cosine is this over this, so negative root 8 over 3. And then we put these two together, we get root 3 over 6. And then this can become minus because there's a negative on this one. Root 8 over 6, and then just put them together. And then when you do this one, it's the same story. You're going to use the formula, and you know everything you need to know about theta off of this, and then same with this one. So I hope you've caught on to that. The whole kind of, the meat of the problem is this part, right? Coming up with your triangle. And then just apply the formulas. All right, 47. 47 looks weird. All right, 47, they ask you, they tell you that f of x is sine x, g of x is cosine x, and h of x is tangent x. And for 47, they say, find h of alpha plus beta. Oh, and they give you pictures. Oh, geez, I didn't see that. Okay, they give you pictures. They say alpha is here, and that's x1. That's the point x1. And they tell you that beta is over here, and that this is the point 1/3 y. This is beta. All right, so what would h of alpha plus beta be? Well, h is this function. So if we replace x with alpha plus beta, it's going to become tangent of alpha plus beta, which we know is tangent alpha plus tangent beta over 1 plus tangent alpha tangent beta. I'm actually going to, oh, sorry, this was a minus. I'm actually going to do this a little different. Well, no, I'll stick with that. So let's see. Wow. All right, for this, let's just draw a little triangle, okay? This side's x, this side's 1. Okay, if this is x and this is 1, then this is square root of x squared plus 1. So we just did x squared plus 1 squared equals r squared, calling this side r. And that's x squared plus 1 equals r squared. So then just take the square root and you get square root of x squared plus 1 is r. So we know that this length right here is square root of x squared plus 1. We can do the same thing here. Okay, we have a y coordinate here, and this is 1/3. Let me draw that triangle a little different. There we go. 1/3 here, and we know this is y. So this side is the square root of y squared plus 1/9. So we're taking these two, squaring them, adding them together, and then we take the square root. So there's our triangle here. This is our beta, and then this was our alpha. So what is tangent of alpha? Tangent of alpha is 1 over x. It's the opposite over the adjacent. So this is going to be 1 over x, then plus tangent of beta, it's going to be this over this, okay? So y over 1/3 over 1 minus tangent of alpha, which was 1 over x, times y over 1/3. And do they give you any information? Use the figurative value of Okay. Let's see. Let's keep going here. Feel like I'm missing something here. Okay, so let's try and clean this up a little bit. This looks pretty bad. This is 1 over x plus y over 1/3. It flips up and becomes 3y. So the 1/3 flips, the 3 joins the y, and you have a 1 on the bottom, so it's just 3y. This becomes over 1 minus, again, this flips up, and you get a 3 up here, and then you have the x on the bottom, so you have 3y over x. All right, and then let's just multiply the top and bottom by x to clear fractions. Right through there. So what you get here is x times 1 over x, which is 1, plus 3xy over, and then when you multiply here to here, you get x, and then minus 3y, like that. Yeah. Okay, now, where are they getting these numbers from? Well, okay, I see what they're doing now. They give you here the equation of this circle, which is x squared plus y squared equals 4. And here they give you x squared plus y squared equals 1. Right? Just make sure I copy this down right. Okay, so they give you that information. And so now what we can do is we can try and solve these for, like, replace the x and the y's. Man, that looks like a real pain in the butt. And I don't like that at all. You know what? It's 2:15. Man, you know what? I think I know how they wanted you to do this. Man, that sucks. This can be done. I can keep going with this, but I don't think this is what they wanted you to do here. I didn't do one like this in class because it's bad. Let me do this. Let's go back to here. Okay, this was the original problem. We were here. Here was our pictures. Let's not plug in x and y. Let's actually figure out from this what is x, okay? So let's say if I know y is 1, right? At this point, if I know y is 1, they're telling me x is x, right? I'm going to take this out of here. And then over here, yeah, I'll leave that one there. Going back here, if we go to this, if y is 1, the question is what is x? So go to the equation of this circle and replace y with 1, and you get x squared plus 1 squared equals 4. And 1 squared is 1, so you get x squared equals 3 when you subtract 1 on both sides. That means x is equal to root 3. Just the positive case because the x coordinate is this way. So this is really the point root 3, 1, like that. And then if you do the same thing over here, you can replace the x here with 1/3, so 1/9 plus y squared equals 1. If you subtract 1/9 from both sides, you get y squared equals 8/9. And then you could do plus or minus the root 8/3. So you do the root on top, root on bottom. And the y coordinate here should be negative because we're down here in this quadrant, so negative. So that changes things. That makes this negative root 8/3. And this was 1/3 this side, 1/3. And over here, let me redraw this over here. We have a triangle that looks like this. The x coordinate was root 3, the y coordinate was 1. And then this triangle over here is this one. So let's just see how much easier this will be now that we have solid numbers in here. If I want tangent of alpha, I go to this triangle right here. This is alpha. Tangent is this side over this side. So this is 1 over root 3 plus tangent of beta, which is this over this, which should just give you negative root 8/3 over 1/3, and then the 1/3 flips up, the 3's cancel, you just get minus root 8. Then over 1 minus the same things but multiplied. So 1 over root 3 times negative root 8. And that's it. I'll just leave it like that. I don't like this problem. I mean, it's okay, but not a big fan. Okay, let's look at, I would not expect something like that on a test. I wish I could go back and start that problem over. I was doing everything in terms of x and y, and that was just going to turn into a nightmare. All right, let's go. All right, so we have identities. I don't know if I have time to do these identities. So what I'm going to do is I'm going to skip to 75, 77, and 81, get those out of the way, and then maybe I'll make another video for the identities. Just because the identities, you know that there's an answer, right? I mean, you know what the answer is, you just have to get to it. So, all right, we're going to try and do arc sine of 1/2 plus arc cosine of 0. We want the exact value. So this we kind of did in class. We kind of squint our eyes and we say, hey, that looks like alpha. That looks like beta. So this really looks like sine of like alpha plus beta in there. And that would be sine of alpha, cosine beta, and there's a formula for it, right? But we need to figure out what those angles are. So what we do is we take this and we say, all right, we're dealing with an inverse sine function, so we can only be looking here. The value 1/2 is positive, so we know that we must be up like this. And we actually know that angle. This is one of the common angles on the unit circle, actually. We don't have to do a triangle, that's a common angle. It's a common angle. Where's the y coordinate 1/2 on the unit circle? That's root 3 over 2 and then 1/2, and that happens at pi over 6. So we know that angle is pi over 6. So this right here is pi over 6. And then cosine inverse, to figure this one out, we know that we're in the top two quadrants. And cosine, oh, where's the x-coordinate 0? That happens here. That's the only place. That's pi over 2. So this is pi over 2. So this is really sine of pi over 6 plus pi over 2, which is sine of pi over 6 cosine pi over 2 plus sine of pi over 2 times cosine of pi over 6. And I'll let you do the rest. Those are all common angles. You should get at the end of that root 3 over 2. Okay, 77. Okay, this one's a little different. We're doing sine inverse of 3/5 minus cosine inverse of negative 4/5. I'm going to put those in parentheses. And we're trying to figure out what this is. So again, this looks like alpha minus beta. So we are going to rewrite this as sine of like an alpha minus beta and use a formula. But in this case, it's a little harder. So let me just go right to the formula. Sine of alpha minus beta would be sine alpha, which is sine of arc sine of 3/5 times cosine of beta, which is cosine of cosine inverse of negative 4/5. And then since it was minus, it's minus. Now sine of beta, which is cosine inverse of negative 4/5. And then cosine of alpha, which is sine inverse of 3/5. Okay, let me make sure I'm on camera here. Just barely. Okay, so remember, this is sine of alpha cosine beta minus sine beta cosine alpha. Now some of these just clean up real easy. Sine of arc sine go away, cancel each other out, you get 3/5 times this piece, which also cancels out, so that's also real nice, negative 4/5. But then we have minus, and we have to figure out what these are. So what we're going to do for this first one is I'm going to draw a little triangle for that one. Let me see. I'm in the top here because it's arc cosine. It's saying that my arc cosine is negative, which means I must be in the second quadrant because the x-coordinate goes with cosine and it's got to be negative. So I can draw a little triangle over here. Cosine is adjacent over hypotenuse, so this is negative 4 and this is 5. And if I go through and solve using Pythagorean, I can figure out that this y value is 3. And so this is the angle beta here. If I want to know what sine of beta is, then sine is this over this. So that should just, the whole thing there should just be 3/5. Now I need to know what this one is. So I'm going to draw a different little triangle. I'm dealing with arc sine, so I'm in the first or the fourth quadrant. It's a positive number, so I've got to be up in the first quadrant. And it's got to be sine, arc sine is opposite over hypotenuse, which means that this adjacent side is 4, and it's positive 4 because we are in the first quadrant. So now what I wanted to know is what is cosine of alpha? And this is the angle alpha. So cosine is the adjacent over the hypotenuse, so that's 4/5. So we get negative 12/25 minus another 12/25 is negative 24 over 25. All right. And 81, just enough time. Should be able to get this last one. Cosine of arc sine of 5/13 minus arctangent of 3/4. All right, so now that I know I'm going to make it to the end here without a time issue, I'll take a little more time on this one. So again, you kind of squint your eyes enough and you can see that this looks like cosine of alpha minus beta. And according to the formula, this should be cosine of alpha. So cosine of arcsine of 5/13. Cosine of beta, cosine of arctangent of 3/4. And then plus, because of the formula, sine of alpha, so sine of arcsine of 5/13, and then sine of beta, so sine of arctangent of 3/4. All right, so just again to stress this, we have cosine alpha, cosine beta, plus sine alpha, sine beta. And I'm going to go figure out what these are off their triangles. Are any of these clean? Yeah, this is the only one that doesn't require any work. That's just 5/13. So I'm okay with that. Let me try and come up with a triangle based off of this. So I'm dealing with arcsine. That means I'm only in the first or the fourth quadrant. It's positive, right? This is positive, so I must be in the first quadrant. And that means my opposite side must be 5 and this must be 13. And we did that one earlier and I messed it up real bad. But when we do this, this should be 12. And it should be positive because it's in the first quadrant. So this is our triangle based for alpha. And then let me go ahead and get the information for beta while I'm here. And you know what? I don't want to do it right here. For beta, let me do the one for beta up here. So for beta, I'm going to use this information right here. I'm dealing with arctangent. So since I'm dealing with arctangent, again, I'm in the first and fourth quadrant. The only way that the arctangent can be positive, that means your y divided by your x coordinate is positive, you have to be up in the first quadrant. So we have to be up here like this. And this should be opposite over adjacent. So this should be 3 and this should be 4. And Pythagorean will let us get this side as 5, and that's your beta. So now, remember, what we're really asking ourselves is what's cosine of alpha? Here's alpha. Cosine is this over this. So this should be 12 over 13 times. Now what's cosine of beta? Here's beta. Cosine is 4 over 5. And then plus this, which we already know. And then this is really saying what's sine of beta. So you go up here, sine of beta is this over this. So that's going to be 3/5. So times 3/5. So when we multiply across here, what's that? 50, 65 on the bottom. And on the top, 48. Plus here, 15 over 65 again. 50, 63 over 65. There we go. All right, hope that makes sense. I got to run.